Okay, we're good to go. So as Andy said, this is now about Koneki and more about the tooling perspective of what we are doing regarding M2M at the Eclipse Foundation. So Koneki is also a Maori word, which means this place here. We thought it was kind of interesting to use it not only for the word for the play word on connecting, but also because in M2M, this is about having devices everywhere, but at some point you want to have them talking to each other no matter where they are. So M2M, and you talked about that a bit already, these are basically all the technologies that allow devices, objects to connect with, to communicate with each other. One example of an M2M application might be a healthcare application where you have maybe some pill boxes that are intelligent, that are able to tell you whether the pills for Tuesday maybe have been used, that kind of stuff. You may have a heartbeat sensor, a weight scale, and all these may be able to communicate directly with the internet because they would embed maybe a SIM card and have their own connectivity, or use a specific gateway to get access to the internet. And what you want to do on the right-hand side of the drawing here is that you want to actually use the data. You want to be able to have applications making use of the data being published by different sources. So yeah, the problem, we have many. This was one example of an healthcare solution, but you have everything related to automotive. You want a car to be able to contact the emergency people when there's an accident, for example. You have many different use cases, and very often when someone wants to come up with an M2M solution, he will develop everything from scratch, or at least with their own communication protocols, using specific hardware, writing specific pieces of software, and there are many areas where M2M is fragmented actually. So what we want to do, thanks to the M2M Industry Working Group initiative, and what we want to try to achieve at Eclipse, is to not only work on the communication protocols, identifying what would be a handful of protocols very well appropriated for M2M communications, but also provide actual frameworks that people can build their own solutions on top of. When you want to write a mobile application, you may use Android or iPhone. You have an SDK to do that. You have a set of APIs to interact with a touchscreen, etc. We want to establish the same thing for M2M. When you want to interact with a temperature sensor or with a GPS device, this is always the same thing for every M2M application. So we want to establish a framework so as there's a common ground for people to develop their own M2M applications. And of course, to support that, we also need good tooling, so as people can write their application, can monitor what's happening on the devices they are developing applications for, and all that kind of thing. So this is basically the purpose of the Koneki project. We aim at providing M2M developers, M2M solution developers, with tools that will help them in not only writing and developing the actual software that will collect a temperature, send a temperature to a server, that kind of stuff, but also help them simulate their solution. You might want to start prototyping something even though you don't have the real hardware already, so you want to start communicating with the server, simulate the server, simulate the device, that kind of stuff. And yeah, in general, being able to test and debug your applications better. So this is where we see room for a common set of extensible tools in terms of helping with embedded development, providing real good support for embedded programming languages such as Lua. We will talk about that in just a few minutes. Good support in the tools for the communication protocols, providing simulators, maybe also tools that will help estimate how much bandwidth such or such protocol may use in such or such scenario, and also provide tools to interact with servers to see what's happening behind the scenes when you have a device communicating. So this is basically the purpose of the Koneki project, which was created last year actually, and our initial contribution was around providing tooling for Lua developers. We will see in a few minutes why we picked up Lua and why we think it's important to have real good tooling for Lua developers. And then on the protocol side, we provide an OMADM simulator. I will give you a very short introduction to OMADM at the end of the presentation. This is basically a protocol used to manage remotely devices such as mobile phones or any kind of mobile kind of device remotely. And the good thing is, even though the project only is 1 year old, we will already be part of the Juno release train. So at the end of June, next month, we will be part of the official Juno 3.8 Eclipse release. So the Lua development tools, the OMADM simulator, these will all be available in an official release. So yeah, kind of to summarize where we are, the three main pillars of Koneki are about, as I said already, providing tools for embedded development to help manipulate protocols and to help manipulate M2M servers. So this is where the pieces of the puzzle we already have. And the big contribution and the work we've been doing last year was on the Lua side. Lua is a programming language that we actually use in our own Sierra wireless devices to provide our customers with a way to write their own application. They don't have to learn about C, to learn about Java, to learn about specific Linux, whatever APIs. We provide them with kind of a DSL actually to develop M2M applications, and this is based on Lua. Lua is a language, a scripting language that was invented initially to be powerful, fast, lightweight, in that it should be really easy to embed in any kind of device, really easy to port on weird small microcontrollers or small different OS on different OSs, and this is really the original goal of Lua, to be very versatile and very small. So the idea behind Lua is that you have kind of a virtual machine that you can easily embed in an existing application to provide an environment that will allow other applications to evaluate it, to run code that is actually compiled at runtime, compiled into bytecode, so it's very performant, and you have good performances with Lua applications. And this Lua runtime is a very small set of C files, plain NCC files, that you can really easily port to any kind of target virtually. Not an Arduino. Arduino is too small in terms of RAM and ROM, just a bit too small. But on bigger microcontrollers, you have flavors of Lua that are able to run. So this is why this is very appropriate for M2M to target Lua, in our opinion. And as I said already, Lua is very kind of a scripting language that we will use to build your own DSL. We build our own domain-specific language for M2M, which is very easy to write an M2M application, which is easy to read, easy to write even from someone which is not a programmer, maybe. Lua is used in a lot of area, a lot in the video games industry. The World of Warcraft video game, for example, you can write extensions to the core game with using Lua. Adobe in Photoshop and Lightroom, they are using it as well, and lots of embedded platforms are using Lua. Of course, we are, but there are many different chip manufacturers that provide a sort of a Lua addition to their core firmware functionalities. So Lua is a great language by itself, but since it's so small, so dynamic as well, we need to have good IDE support, and this is the point of the Koneki project. We want to provide a tool to help people write Lua applications, to have all the kind of stuff you would expect from an IDE, actually. And yeah, this is because Lua is dynamic, that this is one tricky part, providing good content assist, good assistance to the developer when the language is dynamic can be tricky. And as well, the language is embeddable, which means that it might run on some weird microcontrollers with not even a file system. So we need to have some kind of support in the IDE to be able to run an application remotely, even though it's not a file that you will deploy on the target, it might be something different. We need to have support for that. So this is where we started working on Lua development tools, and what I will show you actually is the state we are at the moment in terms of M2M development. In terms of Lua development, we've been working on how to provide content assist, how to provide code navigation, outline, syntax highlighting, and all that kind of stuff. And I will show you how it can be used there, how you can use LDT to go a step further in terms of M2M development by using the Lua framework that we are developing at Sierra Wireless. So the demo I will show you is using MQTT, using the Lua MQTT client Andy was talking about, and we will have a wireless gateway, which is kind of see it as a small computer with wireless connection. That's fine. That's wireless. That's why it's called. So this is basically a small computer with a SIM card in it and a GSM connection, and on the serial port of this small Sierra box that's programmable using Lua, I've plugged a Zigbee modem, and I have a network of two wireless Zigbee sensors that send every 5 seconds or so temperature and an illuminance value. They broadcast these values to the local radio network, and then my embedded Lua application is using the MQTT Lua client to publish messages to the MQTT broker running at Eclipse, and I have a mobile phone application that subscribes to the topic and display the values of the data on the sensors. So, and both these applications, I both write them using LDT because actually they are both written using Lua. The first one using the embedded application framework that Sierra Wireless is providing. I'm collecting the data, publishing it to the MQTT broker, and on the other side I have an application written using the Corona SDK framework, which is my mobile application, also written using Lua.
Is that open source?
Which one? Corona SDK is not open source, but there's kind of a trial mode that allows people to easily evaluate the solution. But of course, at the end of the day, Corona is often used for mobile games and so on. So they show one day their piece of the cake when it comes to selling games on the Apple Store and stuff like that. So it's not open source and it's not that free. So this is the Lua development tools environment plus the plugins that we provide, the Sierra Wireless plugins we provide to interact with the actual device that my computer is connected to. So if I go to the Lua development perspective, I will just, purpose here is not to show you much about the tooling, but more to show you that the Lua code that we have written to get the data out of the sensors and publish the data to the MQTT broker is literally 100 lines of code. This is basically an infinite loop. So you can see that the Lua code is pretty easy to read. When you have an infinite loop, this is why it's true. And what I'm doing is actually getting data out of my serial port and analyzing it. And then, as soon as I detect the payload in the messages I get on my serial port, I'm using the Lua MQTT client to publish the information on the MQTT broker. And what's interesting in the Lua development tools is that even though I'm not that familiar with Lua or the Sierra Wireless embedded framework, I have the content assist in the environment that helps me discover what are the APIs I can have access to. For example, if I want to manipulate the MQTT client, I certainly have access to the MQTT client using the content assist. And what are the methods available on the MQTT client? I can connect to a specific broker. I can disconnect. I can publish things, and you can see that we have the content assist available. And this is a really nice feature. And where it's even going a step further is that even though Lua is very dynamic, we are able to do a lot of code analysis, which will allow us to provide content assist even for weird cases, or at least complicated cases, where I'm doing things like giving the variable an alias, which will be, I don't know, M2M. This is an alias to the MQTT client, and I should have the content assist on my M2M variable. So this is really what Lua Development Tools is about, providing nice features, plus of course the outline, the content assist, the ability to fold the source code and stuff like that. So this is my my application, and what I'm using now is the ability provided by the environment we built on top of Lua Development Tools to run my application remotely. So this will be automatically copied to the Sierra Wireless router, and this will be then run, and I will have beta being published on the MQTT broker. So hopefully, I don't know why I don't have the full screen here. Let's try one more time. Okay, so that's a big fail for the demo. But anyway, so purpose was more to show you that yeah, with Lua, the application is really small, and since it's an interpreted language, actually a scripting language, the source code that you will write once will be portable anywhere. You know, the MQTT library is basically some Lua source code that I can use elsewhere. Same for my XB driver. I can use that on different kind of hardware. You know, usually in the embedded area, you deal with C library that you have to cross-compile to some weird targets, and this is where Lua is interesting for M2M, being able to reuse source code more effectively. A couple of pointers regarding Lua and LDT in particular. Same as for PAO, we would love to have your feedback regarding Lua Development Tools. Lua Development Tools is available on an update site on the Eclipse marketplace as well. So this is really easy for you to give it a try and install it in an existing Eclipse application, or downloading it as a standalone RCT product for either Linux, macOS, or Windows. So that's it for Lua. I may try to save a couple minutes to try again the demo. The next, as I said earlier, the next important aspect we have in Koneki is providing more than just tooling for Lua, but tooling for M2M in general. And one of these aspects is providing good tooling for OMADM. OMADM is an XML-based protocol that is used in the mobile industry to remotely manage the communication devices that you have in a mobile phone, in that kind of device that Sierra Wireless provide. And this is about being able to remotely upgrade, for example, the firmware of the mobile chip, being able to configure some specific monitoring scenarios about the signal strength. For example, you want to monitor whether the GSM signal is doing great or not. So you can use OMADM to do that. And since OMADM is a standard protocol from the mobile industry, it can sometimes be very complex, and there's the need for a simulator to be able not to run the OMADM client on the real device, but more to be able to have a simulated device running right into your IDE and having traces and information about what's happening behind the scenes. So we are providing an interactive simulator in Koneki, and this is basically a form editor and the ability to configure different scenarios and see what's happening when you're communicating with a specific OMADM server. And what is next in Koneki? We want to work on providing more tools For example, now that we have a good Lua development tools environment, a next step would be to provide tools that allow developers to describe a little bit formally what is the data that they want to manipulate. If they are building an automation solution, that would be describing that they are manipulating a temperature in a given unit available on a given kind of sensor that you interact with using a specific protocol. You describe that kind of information in sort of a model, and then you have tools that helps you generate or scaffold pieces of your source code, for example, pieces of Lua source code. So this is one thing we would like to look at for the next release and for the next milestones of Koneki, as well as tools to help estimate bandwidth. That is, as soon as you have a given communication scenario, let's say I want to send a temperature every hour using a specific encoding format, how many bytes will I actually need to pay to my internet provider? And isn't there a communication protocol that would be more appropriate for such or such scenario? So this is one other thing we are looking at. And maybe the most important part, now that we have good Lua tools, and now that we are kind of convinced that Lua is a great approach for M2M development and to simplify M2M development, we are looking at providing an actual embedded M2M framework. I mean, the set of APIs that people need to use to interact with the serial port, the GPS, interacting with the server, being able to know whether or not the internet connection is available. This is something that we want to provide. So the Lua framework that we have been working on, it will likely, or at least some pieces of it will be available. And of course, Koneki will have more and more support for that kind of runtime. And yeah, this runtime is in Lua. So this is we think this is why it was important actually to start by providing good Lua tools. I'm going to try to have the demo working again. Okay, so my logistical assistant is telling me that maybe we can see if there are a couple of questions, and there's something wrong. I may have plugged it on the wrong USB port, and then my network connection is kind of messed up. Yep, Steffen?
Via which type of connections can you communicate data from the embedded device to the internet? I mean, it's clear that you support wireless networks, for instance, but do you also support things like power line communication?
In our devices, we have Ethernet connection. First, if you want to have kind of a fallback connection mechanism, you can use Ethernet, and then this is a 3G/4G LTE communication model that is the main way to communicate. We have also extension cards to provide a Wi-Fi connection, but I don't think we have WiMAX or that kind of thing, or PowerLAN or other kind of connectivity channel or connectivity providers.
Is there a way to extend the communication protocol so that you can add support for new communication channels like?
But I'm not very familiar with the protocol you mentioned, but to me this is more about the transport. I mean, usually in M2M you have you want to have internet connectivity, IP connectivity, and then you use a specific protocol embedded in that, like MQTT, like maybe HTTP and JSON, and this is where we think it's important to provide tools to.
TCP/IP based.
Yeah, usually that's the case.
Connect to the internet through the broker.
checking what you have as Wi-Fi.
Oh, that's the Wi-Fi. I opened the computer, but we just need to go on the internet once. That's fine. Thank you, Andy.
And another question.
No, that's not. Sure. Yep.
Just another question. The one is the runtimes for the Lua, which you have to add to your embedded applications, are they also open source or they are only available on a commercial basis?
Can you say that again?
The runtime for executing the Lua code in the embedded device, are these runtimes also available in open source or they are only available in as commercial products?
Yeah, my point was that actually at the moment this is not open source, the Lua runtime is not, but the point would be to have it open source so as it can be ported on different. At the moment, this Lua runtime, this Lua VM is running on top of Linux, on our own flavor of Linux, but the point would be to allow it to be ported on different flavors of Linux, or maybe on some small microcontrollers. So, but yeah, at the moment, and that's why I try to highlight the fact that we built also in the same. I mean, the runtime is proprietary, and that's why we also provide an IDE on top of Lua development tools that adds a couple plugins that allows to interact with this runtime. This is not open source because it wouldn't mean anything to provide this remote communication and remote system management stack in open source, at least not yet. Thanks so much, Gaëtan. So the Lua application, the 100 lines, apparently they are not that easy to run, but now they are. The wireless gateway is communicating with the internet using the SIM card and the internet connectivity provided by SFR or I don't know who. And we have this wireless station broadcasting wireless radio frames on the network. And we get that, and we post it to the MQTT broker, and we have on the other side the mobile application. So as it is easier to see for you, I'm running the Corona simulator, so you will see a mock mobile phone. So here is the application that I could actually run on my Android phone if I would still have some battery, which is not the case, unfortunately. And we have the two wireless stations that, I mean, we see the two values from the two wireless stations, and one of them, I think that's this one. If I turn it into direction of the light, we should see that its light level should be increasing, but that's not where the important aspects is. I think that's the other one. Just turned off for some reason. It just turned off. No more battery on this one. So that's really a crappy demo. Sorry about that. Thank you so much. Weird products. We are 2 minutes late. I think that's fine. Next speaker on stage will be Fred from Snotlab. This is kind of the third talk in a row about M2M. And he will talk to us and make a keynote about what open hardware is, what are the relationships between open hardware and open source, and what are the kind of business models that companies such as this company are building on top of open hardware, and how they are making money not only out of free software but also out of kind of free hardware. So, welcome, Fred.